3 slides, and I'm going to talk about some of the other choices you have within RDMA, besides RoCE and RoCE v2, and then also give a quick update on FC-NVMe. So if there's one message you can take away from my slides, it's that there is choice. There is choice within RDMA, and there is choice within NVMe or fabrics, and we'll cover those options. So Rob covered in great detail RoCE v1 and v2, and what I'm going to do is I'm going to attempt to introduce another third option, which is iWARP. So I think just to set the stage here, RoCE v2 assumes that there is PFC or priority-based flow control in the fabric. And what priority-based flow control means, you are actually enforcing on a per priority, on a per port basis flow control. But you are not doing flow control at a per flow level. That's where the problem comes. If you are not able to manage traffic, then you run into head-of-line blocking issues. And to solve that, something called DCQCN, which is end-to-end flow control, congestion notification management, has been implemented that Rob was talking about. iWARP, on the other hand, is built on standard TCP/IP framework that we already have in our data centers today. So it uses standard switches. It doesn't expect any DCB configuration, which is a key requirement for RoCE v2. So for RoCE v2, you have to make sure that if you have a multi-hop configuration, your priority settings are consistent across all these hops, because PFC is a link level protocol, and you have to make sure that each hop is consistent across the fabric. But in the case of iWARP, you can go across a WAN, and you don't have to worry about congestion management. It's really about congestion avoidance at that point in time. I think I've laid down the way the protocols are layered for ease of understanding. So then the question becomes, which one do I choose? First of all, a quick update. These technologies are available in shipping, RoCE v2, iWARP, and I've listed some of the vendors that support RoCE and iWARP, and I'm sure some people will realize who can support which one. So where does iWARP shine? iWARP shines when you have a larger deployment, and you can tolerate a little bit of a latency. On the RoCE front, you will get deterministic latency because you are using lossless Ethernet framework, DCP-based PFC framework, but then it has the added concern around managing the configuration across the entire fabric. So you have to be more careful with your configuration, and usually RoCE v2 will be configured in a smaller, like a top-of rack, although there are at least one large configuration I'm aware of which has RoCE. But usually, typically, RoCE will be in a smaller configuration, and iWARP will be over a larger WAN kind of scale network. And we'll take questions at the end. So FC-NVMe. So like I said, I think if there's one takeaway, it's that as a customer, as a vendor, you have a choice. You have a choice between RDMA and FC today, and TCP tomorrow, as that project gets approved. Within RDMA, you have different transports, and FC is also one of the transports that is being actively worked on. There is a T11 committee that's actually meeting right this week, and we're hoping that the standard will get ratified tomorrow. If it does, then we'll make an update. If not, we'll keep tracking that actively. But before I go into FC-NVMe, if you are not familiar with FC, most block storage, mission critical, storage traffic today in the data center runs on Fiber Channel. And Fiber Channel is a fully offloaded, zero-copy transport that delivers deterministic and highly scalable performance. Based on some data I picked up at FCI from an FCI website, there are over 100 million ports that have been shipped and over 40 plus million deployed today. And about 12 million ports get shipped every year. So the numbers are big. FC is a protocol that was built from the ground up for storage, and it does storage only. So today, Fiber Channel carries SCSI and FICON, and now we're adding another protocol mapping called NVMe, which is really a ULP or an upper level protocol mapping. So that's where it sits. So the reason why I'm showing this picture is all the underlying layers are able to, you can leverage it for your FC-NVMe transport. So we talked about the standard, things are going well. And there are some enhancements that are being planned for the next revision around enhanced error recovery. This was covered in the previous panel also, but there is a significant amount of community work that has been going on to get the transport up in 410 and 412. And host and target drivers are in different stages from different vendors in terms of upstream submissions. If you're interested in doing an POC, you're welcome to contact the adapter vendors as well as the switch vendors. Because the standard hasn't been ratified, the support is not GA'd yet, but we do have pre-GA code available for you to play with, and we've been demonstrating it all the way since 2015. And I think it's important to call out that there's a lot of ho-hum around where is FC going and what is the future of FC. I think if you, I don't know how many of you know this, but over 80% of AFAs connect to Fiber Channel today. So AFAs, if AFAs are a growth vector for the storage industry, so is Fiber Channel.